How to solve a linear programming problem in two variables by graphing. Once you have a linear programming formulation, just like what we did in the previous video, you can now solve the system by graphing. Step 1, graph the inequalities, which entails taking the intersection of half planes. You've seen this in section 7. This will give you the feasible region, meaning that the set of all points in that region will satisfy the linear programming problem. However, those points are not optimal. You want to get the solution that will maximize the objective. You can find the candidates at the corners of the feasible region. For example, if this happens to be the feasible region, these are what we call corners. That's where the maximum or the minimum will occur. So we get the value of z at each corner and come to the conclusion that the corner point with the highest value of z will give the maximum value of z over all points in the entire feasible region. The corner point with the lowest value of z gives the minimum value of z over all points in the feasible region. Now go to desmos.com/calculator. And we will use this graphing tool to solve this linear programming problem. The first step is to graph the linear inequality. Okay, look at what happened. It became red. And let's see what's going on. If we get the intercepts of the boundary line, which is 20x plus 10y equal to 80,000, and we set y to 0, we'll be left with 20x, 80,000, or x equal to 4,000. We divided both sides by 20. So this is your intercept. 4,000. Do we see 4,000 here? No, because it's 0, 1, 2, 3, 4, 5. Numbers are very small. So we have to zoom out till we have that 4,000. See, there it is. And likewise, we can calculate the y-intercept, which is set x to 0, you're left with 10y equal to 80,000, or y is 8,000. You can eyeball the intercepts and we see that we are correct. So this is really the line. Now, take note of these. X greater than or equal to 0, y greater than or equal to 0. We don't need to graph these because this just means first quadrant. X coordinates are positive here and y coordinates are positive here, so it's this whole quadrant. Let's now go ahead and graph the second line. Again, from the equation, you can see right away that the x-intercept and the y-intercept are both going to be 6,000. Now, where does the blue and the red intersect here? Let me use the green one. They intersect right here. And everything inside. So now we eyeball the corner points. 2,000, 4,000. So let's write that here. And we're going to click label. We eyeball the next one here. 0, 6,000. Of course, we have already calculated it earlier. 0, 6,000. And we want to label it. Another one here. Label it. And lastly, we never forget about 0. So those are our corner points. We now make a table. Compare the z values. So we have to put the z here. 10x plus 6y. And you create a table with the x. So that has to be x. And this has to be y. We're erasing the subscripts and this one will be z. I think we have to put this on the top and put Z here. So we have a 0 and a 0, and that gives us a 0. You put 2,000, 4,000, it gives us 44,000, 0, 6,000, 3,600. Am I missing something else? 4,000. And you can check these with your calculator. Check these values with your calculator. So based on this table, we can see that the maximum. So our answer is 2,000 containers of water and 4,000 medical kits will give us the maximum number of people helped, which is 44,000. This is the maximum. And that's how to solve a linear programming problem in two variables by graphing with Desmos. In your Chapter 7 test, you will be allowed to use Desmos. 80% of the content of that test will be word problems. You will have more opportunity to practice with word problems in 7.5 Part 2 and the upcoming group assignment. Thank you.